Hey, trick class, we're going to look at this problem from the 9-3 homework set, the law of cosines. And what we have here is what we could refer to as an SAS triangle, meaning we're given a side, the angle between another side. So side, angle, side. And when we have the side, angle, side, we need the law of cosines. We can't use the law of sines. Because if you recall with the law of sines, I need an angle and the side opposite, and I don't have the side opposite here, and I don't have a second angle with a way to come up with one of these opposite side pairings. So I can't use the law of sines, so we need the law of cosines here. So this is what the law of cosines says. This is one of the three different forms that you see in your notes, but this is the one that's isolated for B, being the unknown side length. And if you just needing the other two, like if I needed A, I would just switch A and B. Everywhere I see an A, there'd be a B. Everywhere I see the B, there'd be an A, and that would be an A. So it's the same thing. It's just each one has its own form for which side length it is isolated. That's opposite the angle in that SAS format. Okay, so all of them have their own form, but they're all the same form. They all have this look to them. So what I need to do here is to solve for B. I need to call this one is A because it's opposite side A. So this little a is 3 squared. Right, this is opposite angle C, so that is 4 squared. And then minus, now I'm multiplying the A and the C together, so the 3 and the 4. So this is 2 times 3 times 4 cosine, and then angle B is the angle that's opposite side B. So that's the 30 degrees. All right, so just simplifying a little, 3 squared is 9, 4 squared is 16, 2 times 3 times 4 is 24, and then the cosine of 30 is square root of 3 over 2. And then I can divide the 2 into the 24 and get 12. So there's, B squared, but I want B, so B is all that, and then we would approximate, typically like 2 places. So that's about 2.05. But now that I have B, 2.05, I do have an angle and its side opposite. So now I can switch to the law of sines. So I can find angle C or angle A with the law of sines. All right, I'm going to go to the 3. All right, and the reason I'm going to the 3 is this is obviously the smallest side, so it's going to be acute. 3 is the next smallest side, so it definitely would be acute, because it's the middle side. 4 is the biggest. If there was an obtuse angle, it would have to be C. I don't want to find any angle that could be obtuse with the law of sines. I can find angles that are obtuse with the law of cosines, but I don't want to do it with the law of sines. So I'm not going to solve for the largest angle with the law of sines. So I'm going to do the sine of A is to 3 as the sine of 30 is at 2.05. All right, and that's going to allow me to solve for A. So there's what I get when I isolate A. Now I'm just going to go into my calculator. All right, so A is approximately 47.03 degrees. And now the only thing I don't know is angle C, and I can use the 180 rule there. So 180 minus 30 minus 47.03. So that's 102.97 degrees. So it's good that I did not use the law of sines to solve for angle C in the middle like we did right here, because remember, I use inverse sine to solve for that first angle after I use the law of cosines, and the inverse sine would not give me an obtuse angle. Remember, it can only output between negative 90 and positive 90. It can't output 102.97. So it would not have given me this, and I would have had to I would have adjusted and had the wrong side lengths basically. So make sure that when you do this order, right, you do law of cosines for side 3, the law of sines for the smallest remaining angle, and the smallest remaining angle is going to be the angle that is opposite the smallest remaining side. Okay, so we found this one. That was the smallest side. So this is the smallest remaining side. This was the largest. And then the 180 degree rule for the last angle. All right, that way you'll avoid the law of sines on the largest angle which cannot find an obtuse angle.